ladies and gentlemen. Welcome back to Physics 20 Vectors, Lesson 1, Vectors in 1 and 2 Dimensions, Part 3. Now, breaking factors into components. Being able to move forwards as well as backwards is a big idea in math and physics. So, therefore, I think that it makes sense that if we can add two vectors together, we can also take the resultant, to make one resultant vector, we can also take the resultant and break it into two new vectors called components. Okay? Or work backwards. So, a crow flies at an angle 30 degrees north of west with a velocity of 5.5 meters per second. What are the components of this movement? Well, step 1, draw out a vector diagram on the Cartesian plane. So, north, south, east, west. So it flies 30 degrees north of west. So it goes, north, east, south, west. So it goes 30 degrees north of west. So it goes west, and then it swings north to make an angle of 30 degrees. And the resultant is 5.5. Okay? 5 meters a second. So, step 2, draw and label the x and y components. Use proper vector notation. So, this would be the y and this is the x. So, step 3, using trig ratios, determine the measure of the components. Determine the measure. This is called breaking the vector into components. So, back here. So we have the x and the y. Now, I'm going to say sine of theta is opposite over hypotenuse, or opposite is hypotenuse times sine theta. Now, in this instance, for this angle, the opposite is x. So 5.5 times sine of 30 degrees. It should be 2.75, but let me double check. I'm getting old. Be quiet. 2.75 meters a second. Now, the y component, the adjacent, or adjacent, so hypotenuse cos theta, so y is 5.5 cos of 30 degrees, or something, I can't do that in my head. 5.5 cos 30 is 4.76. Yes, I can round that off to 4.8, but that may or may not be my final answer. All right? And I'm not going to yell at you for going to 3 significant digits. All right? So this is breaking the vector into components. That's what I need to be able to do for standard right angle triangle. Okay? So let's do a couple of here. So, determine the north and east velocity components of a car traveling 100 kilometers an hour, 25 degrees north of east. Okay, so car's going east and swings north to make an angle of 25 degrees. And this is 100, not 110. What am I smoking? 25 degrees, 100 kilometers an hour. So we have to figure out the x component and the y component. Now, that's the opposite and adjacent. So, out of habit, I start off with sine. Sine of theta is opposite over hypotenuse. Opposite is hypotenuse sine theta. Now, in this case, the opposite is the y. That's fine. 100 kilometers an hour times sine of 25. Is that 28, 26? Why don't I just calculate it instead of guessing? 100 sine 25. Ooh, more than I thought. 42 point, yes. 2.3 kilometers an hour. Now, cos of theta is adjacent or hypotenuse, or adjacent hypotenuse cos theta. So now in this instance, the adjacent is the x side, 100 kilometers per hour, cos 25 degrees. 90.6 per hour. All right. Now, how will we check this? Well, we'd use Mr. Pythagoras. I'm not going to do that. You can if you want. Now, what I am going to do is ask you to do this one without my help. We'll come back. I'm going to pause the recording. I'm going to do this. We're going to come back and compare answers, okay? Good. Okay, ladies and gentlemen, welcome back. Now, I got my x dimension is 8.4 meters, or, now, I apologize, I should be saying 8.4 meters east and 5.4 meters south. If I just said 5.4 meters, that implies, well, I'm not giving you a direction. All right. And by the way, I did double check this with the Pythagorean theorem, and I got an exact value. My hypotenuse is 10, so I didn't bung it. All right. Anyway, that's it for me. Please work on your vectors lesson 1 classwork, and if you got any questions, shoot me an email. Otherwise, good luck.